period 3 elements and the oxides. This topic, it's only 2 pages in the CGP textbook, but 2 pages full of equations, full of reactions, the pHs you have to learn for which reaction. Let's get into it. So, sodium oxide, Na2O solid plus 2HCl aqueous from 2NaCl aqueous plus H2O liquid. MgO solid plus H2SO4 aqueous from MgSO4 aqueous plus H2O liquid. SiO2 solid plus 2NaOH aqueous from Na2SiO3 aqueous plus H2O liquid. P4O10 solid plus 12NaOH aqueous from 6 to form 4Na3PO4 aqueous plus 6H2O liquid. Let's go through this one again. P4O10 solid plus 12NaOH aqueous from 4Na3PO4 aqueous plus 6H2O liquid. SO2 gases plus 2NaOH aqueous to form Na2SO3 aqueous plus H2O liquid. SO3 gases plus 2NaOH aqueous to form Na2SO4 aqueous plus H2O liquid. Al2O3 solid plus 3H2SO4 aqueous from Al2 bracket SO4 bracket 3 aqueous plus 3H2O liquid. Al2O3 solid plus 2NaOH aqueous plus 3H2O liquid to form 2NaAl bracket OH4 aqueous. Why does sodium hydroxide form a more alkaline solution than magnesium hydroxide? Sodium hydroxide is more soluble in water, therefore more alkaline solution than magnesium hydroxide. Ionic oxides of metals slash sodium slash magnesium contain O2 minus ions. When they dissolve in water, the O2 minus ions accept protons from the water molecules forming hydroxide ions. Now for this topic, it's best to just learn all of the key in-depth details, like even this, because it's such a short topic. It's only 2 pages, right? And obviously, yes, a bunch of equations and that, but just keep reviewing it and eventually you know all of them, right? Ionic oxides are alkaline, Na2O solid plus H2O liquid form 2NaOH aqueous, pH 12-14, MgO solid plus H2O liquid form Mg bracket OH squared aqueous, pH 9-10. And remember, sodium hydroxide, why sodium hydroxide form more alkaline solution than magnesium hydroxide? Because it's more soluble in water. Simple covalent oxides of non-metals and ionic oxides are alkaline. Simple covalent oxides of non-metals, phosphorus and sulfur, form acidic solutions. pH solutions are 0 to 2, strong acids. They dissociate in solution forming hydrogen ions and a negative ion, aka conjugate base. P4O10 solid plus 6H2O liquid form 4H3PO4 aqueous. SO2 gases plus H2O liquid form H2SO3 aqueous. SO3 liquid plus H2O liquid form H2SO4 aqueous. Phosphoric 5 acid, sulfurous acid, sulfuric 6 acid, and then H3PO4 aqueous, arrow 3H plus aqueous plus PO4 3 minus aqueous, then H2SO3 aqueous, arrow 2H plus aqueous plus SO3 2 minus aqueous, H2S4 aqueous, arrow 2H plus aqueous plus SO4 2 minus aqueous. Al2O3 partially ionic and partially covalently bonded, therefore it's insoluble in water. Partially ionic and partially covalently bonded is also soluble in water. Giant covalent structure of silicon dioxide. Well, it isn't soluble in water, but silicon dioxide, giant covalent structure of silicon dioxide, isn't soluble in water, but it can react with bases forming salts, therefore, yeah, so it's classed as acidic. Therefore, magnesium oxide and high melting point sodium oxide, as Mg forms 2 plus ions, bonds are more strongly than 1 plus Na ions in Na2O. Very simple, but if you've never been exposed to these type of questions before, why does this have this? You just look at the charge if it's like 1 or 2 marker, right? We're going to go into more of this. So sodium oxide, magnesium oxide, Al2O3. Now these 3 are metal oxides that have high melting points, form giant ionic lattices, therefore strong force of attractions between each ion, therefore lots of heat energy needed to break bonds / melt them. Why does aluminium oxide have a low melting point than you might expect? Difference in electronegativity between aluminium and oxygen not as large as between magnesium and oxygen. Oxygen ions Al2O3 don't attract electrons in metal oxygen bond as strongly as in magnesium oxide. Bonds in Al2O3 partially covalent. Oxygen ions in Al2O3 don't attract electrons in metal oxygen bonds as strongly. Why is sodium more reactive than magnesium? When they react, sodium loses 1 electron to form an Na plus ion, whilst magnesium loses 2 electrons to form Mg2 plus ions. Sodium takes less energy to lose 1 electron, sodium takes less energy to lose 1 electron than to lose 2. More energy needed for magnesium to react. Reaction of these oxides in water: sodium oxide vigorous, magnesium oxide vigorous, aluminium oxide slow. It'd be faster if it's powdered. Silicon dioxide slow. P410. Phosphorus spontaneously combusts. Phosphorus oxide spontaneously combusts. SO2 burns steadily. 2Na solid plus a half O2 gases from Na2O solid. 2Al solid plus 1.5 O2 gases from Al2O3 solid. P4 solid plus S5 O2 gases from P4O10 solid. Mg solid plus a half O2 gases from MgO solid. Si solid plus O2 gases from SiO2 solid. S solid plus O2 gases from SO2 gases. And then 2Na solid plus 2HO liquid from 2NaOH aqueous plus H2 gaseous. Mg solid plus 2HO liquid from MgOH squared aqueous plus H2 gaseous. That's magnesium rack with cold water. This is magnesium reacting with steam, and like you see that change, liquid to gaseous steam, and it's much faster with steam because more Mg solid plus HO gaseous from MgO solid plus H2 gaseous.